Let's see if that's working. Okay, so this is going to be video from the past paper questions, the mechanics, statics exam questions. I'm just trying a new style. Is that working? Okay, we'll see. So this is, I mean, if you want to find it, it's M2 Jan 2013 Q3. So you'll be able to look that up on Exam Solutions or Physics and Maths Tutor to find that. I just thought it'd be good to have a little video as well. So we have got our ladder like this. We've got A down here, B down here, got alpha here, and we've got C here. Just going to copy the picture down. First thing I do always. Well, that's 3 meters, and the whole thing's 5 meters. So I guess this is 2 meters, right? First thing we want to do, always, is add forces to diagram. So as you're doing these, always draw it out and always add the forces on. So ladder length 5, fine. Mass 18. So the 18, and it doesn't say it's a uniform ladder, but it will be. Let's just read everything. And the other end B resting against a smooth wall. The ladder lies in a vertical plane perpendicular to the wall and makes an angle alpha with the ground where tan alpha, so we've got this going on as well. We know that tan alpha is equal to 4/3. So if that's alpha, remember that's opposite over adjacent, isn't it? So if that's alpha, opposite is there, adjacent there. That means the hypotenuse must be 5 because 3 squared plus 4 squared is equal to 25, which is 5 squared. And it's one of these Pythagorean triples that they always give you. So common. And we might as well do this now. So we've got it. So sine alpha is equal to O/H. So that's 4/5. And cos alpha is equal to A/H, which is 3/5. So that's done for later. The coefficient of friction between the ladder and the ground is mu. So we've got mu. Let's add that. Is that in the... That's not in the picture, is it? That's not particularly clear either, is it? Let's see if we can zoom in. That's a bit better. Okay, so we've got mu. We'll use that in a bit. A woman of mass 60 stands on the ladder at point C. So let's add that in. That we've got 60. G is the force, isn't it? And we've got all the directions there. The length. The ladder is on the point of slipping. Okay, so point of slipping. What that means is we got friction is at mu r. So it's friction max. Friction max is mu r. So that's what we can use. That's why it says that. The ladder's model Z. There it goes. And a particle, find the value of mu. So we've been told it's a uniform rod. That's why I added in the weight of the ladder yet, because we wanted to make sure we want it from the middle. So that's the weight of the ladder, which is 18g. And we know that distance there to there is going to be half the length of the ladder. So that's 2.5 meters. Okay, we then want to add the forces on. So that's still in. We're going to have the reaction at the wall here is always perpendicular. The reaction here is RB, and the reaction here is perpendicular. So it's RA. There's one other force we haven't added in, which is the friction. Now we've got a smooth wall here, so there's no friction there, but we've got a rough floor here. Friction must act against the way the ladder would want to slip. If you imagine the ladder's going to want to slip like that, isn't it? So down the wall and like with the back coming out like that. So the ladder's going to want to slip that way. So the friction must act opposite to that. So friction is there. And I'm going to put also what that friction is equal to right away. So that's mu RA. Okay, so that is what your force diagram should look like. I'm just going to pause it for a second.